Hello everyone, this is Professor Gant again. This is part 2 of the Module 4 homework for Math 109, General Education Mathematics. In this video, we will go over concepts for quadratic functions. In particular, we will learn how to graph quadratic functions and solve quadratic equations using the quadratic formula. The problems that we're going to go over will be number 28, number 29, and then we'll dial back and do number 8. So this first question is more like an applications problem, but when it really boils down to it, what it's about is basically graphing the function and then, of course, finding out information based upon that graph. So it says a plane is dropping emergency supplies to relieve famine in a less developed country. Crates are dropped and the height of the crate above the ground at time t seconds is given by the equation below. Okay, and we want to use this equation to go through parts A through C here. Okay, so the first thing we'll actually do is to graph what this particular equation will look like. Okay, now I'm going to go through this and show you how to do it on your calculators, as well as kind of learning how to do it by hand here. I'm going to do the by hand first. So we have some function h of t, which is 166 minus 16t squared. So some background information. Whenever we deal with quadratic functions are also called parabolas. So you have quadratic function equals parabola. So if you hear any that phrase quadratic function or parabola, know that they're talking about the same thing. Your basic parabola quadratic function looks like this. Y equals x squared, and it just looks like a u. Okay. Now, of course, if we had negative x squared, which is also understood to be negative with parentheses x squared, then of course the graph looks like this. And so let's say now I wanted to add something to this negative x squared. So let's say if I had y equals negative x squared plus 10, then this plus 10, what it does is it'll take this function here that's already opening down, and it'll lift everything up by 10 units. So here, if it lifts it up by 10, remember this point here is the point 0, 0. So this would be the point 0, 10, and the graph will go like that. Okay. And so in general, the graph that we are talking about has to look something like this. Okay. So what we have to do is figure out, of course, some other properties of this graph, mainly how high it goes and where does it cross the x-axis, or in this case the t-axis here. And so we're going to figure out that information by using what's called the vertex form of a, well, not vertex form, but yeah, I guess, yeah, you can call it the vertex form of a parabola. We can figure it out that way by hand. And we'll also solve for the x-intercepts, or in this case t-intercepts, by letting h equal 0. So we'll go ahead and do that now. All right, so if we put this equation here in vertex form, in general, vertex form looks like this, where h is going to be negative b over 2a, and k is going to be this formula here. And I'll explain where all the a, b's, and c's come from. So here, this is vertex form, and this is what we call the normal canonical form here. Okay. And if we rewrote this h here to be like this, then what you'll see is that for here, a is always the number next to the variable with the highest exponent, which in this case, a would be 16, negative 16 in this problem. B is always the number that is next to the variable, that's just its variable, in this case, x. We do not have a variable here with a t, so that means B would be 0. And of course, C is the number that's by itself, which is 166 in this case. So if we rewrote this way, then what this H and this K represent are what we call the vertex of the parabola. And since our A is negative, we know that our parabola is going to open down, and the highest point is going to be this point HK here, okay? So in knowing that, if we were to calculate H here, it would just be negative and then 0 divided by 2 times negative 16, which would just be 0 divided by negative 32, which is 0. And K would be this formula 4AC minus B squared all over 4A. And we could simplify that by splitting this up into two fractions. And when we do, what we get is this formula as a result. And I'm going to use this one since it's shorter. So here we have C, which is 166, minus B, which is 0 squared divided by 4 times negative 16. And here it really doesn't matter what's in the denominator here. It's not 0. 0 divided by anything other than 0 is 0. So we know that this point right here is going to be the point 0, 166. And 0 here, 166. So if I'm looking at this, I know that my graph in general is going to have to look something like this. Okay. The question now is, what are these points? And we can find out those by finding the X-intercepts for this particular function. So just looking at this right now, we know that answer choice A and C are out because they don't look like what you see here. And here we have answer choice B and D that are possibilities. We just have to figure out if these X-intercepts here are correct, or the correct up here for B, or are they correct for D. And so what we'll do is make some room, and we will figure out what that will be for this problem. All right, so to find out the X-intercepts, or as we're going to call them T-intercepts here, we need to figure out what is the value of T when H is 0. So we're going to let H of T equal 0, and we're going to essentially solve for T. Now, whenever we deal with quadratic equations, it is customary to either try to factor or do a quadratic formula to solve them. And whenever you do quadratic equations, you need to have all terms on one side, have the other side equal 0. Because of the fact that this particular quadratic equation, which a general quadratic equation looks like this, when you are missing this term that has the x in it, or in this case the t in it, you are allowed to solve this as if you were trying to do some kind of linear equation here, okay? My point is, let's say if we had something like this, and I set this equal to 0, I am not allowed to come here and do this business, where I subtract 1 from both sides, and then after that I try to, factor over here. I'm not allowed to do any of that. The only time I'm allowed to kind of move stuff around to get t by itself in this case is when I don't have this middle term here. Other than that, you either try to factor out or use the quadratic form. All right, so let's get rid of all this and finish. So here, what we could do, in this case, I'm going to add 16t squared to both sides. That goes to 0. This is 16t squared equals 166. And here I can divide both sides by 16. And that will give me t squared is equal to 166 over 16. Now, it so happens that 166 is the same as 2 times 83, and 16 is 2 times 8. So this has a common factor of 2, so that reduces, and t squared is just equal to 83 over 8. Now, to solve this equation, we have to do what's called taking the principal root of both sides, which is we write t equals, and then we do plus or minus, and then take the square root of everything that we had here. Okay? And so by doing that, this particular equation here, if we were to actually just write that out, is basically saying this. We have some parabola, we have some y value 83 over 8, and we're trying to figure out the corresponding t values that go along with that y value here. And so if you see one of these answers is on the negative x-axis, another one's on the positive. So that's why we have to do the plus or minus and then do the square root. So if we go ahead and put this square root of 83 over 8 in our calculators, I'm going to go ahead and bring up my graphing calculator here to do this. Here, let me make this a little larger. So here, if we do square root, and of course we can do that for the squared button. Above it we have a square root, so we have to do blue, that, and then we will have 83 divided by 8. Move the arrow out, and so you see that we roughly get about 3.221. Okay, so I'm going to minimize that. And here, this will roughly be 3.221. Okay, and so now this should give us a good idea on which answer this is. And according to what I see here, it looks like answer choice number B would be the best one. So I'm going to click on here just to verify. Notice here that both of these t-intercepts are a little bit larger than 3. And of course on the t-axis here we have 1, 2, 3, 4, 5, 6, 7, 8. And we see just right after 3 we have a point. And right after negative 3 we have a point. So it looks like B would be the correct answer choice. Now, verifying also that 166 is the y-intercept. Of course, if we go up to here, this looks like 1, 2, 3, 4, 5, 6, 7, 8. So if we take 200 and divide that by 8, that is going to be 25. So this is in units of 25 going up. So this is 25, 50, 75, 100, 125, 150, 175. So 166 has to be in between 150 and 175. So that works out nice. All right. And so we see that is the answer. Now, if you want to know how to do this in your calculators, I'm going to go ahead and show you that now as well. All right, so to graph this in your calculator, we would go to y equals, and then after that we would do 166 minus, and then 16, and then we'll click this button here with the x, t, theta, and nu. That's our variable button. And we'll click this button here to square. Okay. And now what we want to do is make sure that we set our window to show like what we were talking about in our answer. So here, I'm going to slide this down for a second. You see that the answer we chose, our x values go from -8 to +8, and our y values go from -200 to +200. So that's what we're going to set our window to be. So x min is going to be on the left negative x-axis, so that will be from -8. X max will be +8. The x scale, we'll leave that at 1. Y min will be -200, and Y max will be +200. Okay, and then we will leave the Y scale and resolution, all that stuff the same. The graph, and it should look like exactly what we saw. So that's one way of doing it. All right. So now let's move on to part B. So part B says, are there values of t that would not make sense to use in this equation because of the physical characteristics of the following crate? Okay. Now notice that when we talk about this, I'm going to erase so that I can draw here. We're talking about basically throwing stuff out of an airplane. Okay. And if we do that, realistically speaking, this is our airplane here. We're throwing stuff out of the airplane. It's going to kind of have this path like this. And of course, we're not going to start counting the height of whatever it is that we're throwing out of the airplane until we actually throw it out. So when we start throwing it out, that's going to be at time t = 0. And then of course, whenever it hits the ground, we know there'll be another time greater than 0. So here, if we talk about a parabola, any time that is negative here does not make sense in this problem. Okay. So here we don't want to allow t to be negative. We can allow t to be 0 because that's the instant before we actually throw out or drop the emergency supplies. Okay. All this other stuff really doesn't make a whole lot of sense, but here, making sure that t can't be negative would be the one thing that we have to look out for here. All right, and so now what we want to do is find the time at which the crate will strike the ground. Well, if you notice, that's actually what we just got through doing. So when we got our answer here of t roughly being plus or minus 3.221, those were going to be the times in seconds. But of course, we would ignore the negative answer because the negative answer doesn't make any sense. So this answer here is roughly 3.221 seconds. And since they tell us to round to 2 decimal places, we'll just say 3.22. And that's exactly the place here on the t-axis where the graph actually hits that x-axis there. All right, so that's number 28. Let's move on to number 29. So for number 29, this says we consider a linear and quadratic models used to describe the birth weights, and this is live births per 1,000 women aged 15 to 19, and we're told that the line of best fit is this linear equation, and the quadratic equation of best fit is going to be this quadratic equation. Okay, so when we look here, notice that this is our line and this is our quadratic function. And although both of them do not accurately model the data correctly, as you can see, the quadratic one kind of goes along with the trend or the shape of these points here a little bit closer than the line does. So when they ask which model gives a better prediction for 2005, which is at year 0, if we look here, we see that the quadratic one actually has a point that's almost the same as what the actual data point is here. So we would go with the quadratic model. Okay. Now, when we look at the year 2009, which would be, let's see here, 2005, 7, 9. Yeah, so this is 4 years after. If we look here, this is the linear model. And of course, the black is the quadratic model. And here it looks like, again, the quadratic model is doing a better job of modeling what's going on. Okay. All right, so let's jump back now to question number 8. And this will be our final problem for this particular video. All right, so for this question, we're asked to solve this quadratic equation by using the quadratic formula. And so in general, this is a quadratic equation. And when we're asked to solve this by using quadratic formula, we're asked to use this particular formula here. And how we actually come up with this equation, there's a process called completing the square that we do, and we kind of do all this work to work it around. Since it's out of the scope of what we need to actually talk about in this course, all I'm going to tell you is that make sure that you write this formula down and use it. The important thing that we need to know from the equation that we're given here is we need to identify A, B, and C. And of course, A is always the number next to the x squared, B is the number next to x, C is the number that's by itself. And in this case, since our x's are p's, we know that A is going to be 7, B is going to be 15, and C is going to be 2. And I'm putting this 1, 2 here to express that whenever I do this quadratic formula, I can have up to 2 answers, okay? So one of these answers with the plus will be the x sub 1 answer. The one with the minus will be the x sub 2 answer. So when I go substitute this in, this will be minus 15 plus or minus 15 squared minus 4 times A, which is 7, and C, which is 2. And all of that will be divided by 2 times A, which is 7. So here, negative times 15 is negative 15 plus or minus. And now we got to do all the stuff that's on the inside here. So 15 squared is 225. And here 4 times 7 is 28. 28 times 2 is 56. All that divided by 2 times 7, which is 14. So we'll do this plus or minus. And of course, if we do 225 minus 56, we're going to get 169. All that over 14. And if we continue on here, if we take the square root of 169, you'll find out that that gives us 13. And so now from here, we just separate this into 2 separate answers. So we'll do the negative 15 plus 3 over 14 and negative 15 minus 13. Sorry, I need to put the 13 there, over 14. And if we do negative 15 plus 13, that is a positive 2. Sorry, negative 2 over 14. And we have a negative 15 minus 13, that's a negative 28 over 14. And if we do that, we know a negative 2 divided by 14, that ends up here reducing, being a negative 1 over 7, and negative 28 over 14, all that just ends up being negative 2. So my final answers here are, in this case, P is equal to -1/7, and +2. Let's see, something that we did wrong here, so we need to find out what it is. Let's see. Oh, okay, I see. I forgot to put the negative here, so I just need to put that in. Yeah, and that should be it. All right, so this concludes the second video for the Module 4 homework for Math 109. Again, I'm skipping around so that any other questions that I don't do, those questions should be very similar to the ones that I am doing. So this should be a good comprehensive review on the topics that we need to discuss. All right, so check out the next video that I'm going to do, which is going to include compound interest and population growth. And so I'll go through a basic explanation of that and the equations that we'll use, and we'll go through how to do those problems. Take care.